How about you? Good evening. Such a low batch strength. Others are sleeping. So, how are you all and how's your preparation going on? Very well. Oh, that's wonderful having me. How's your preparation? Hi, Nishita. Bhumi, Vedant, Ayan, Akshat, Dev. हाँ जी, so कैसा चल रहा है सब? As well, having practicals at the nick of time. Oh, seriously? That's actually complex. Good evening, Rafi. So you were not there in the last class? Doing great. You have midterms from 29th, a state board, but subjective examination, Nishita. Oh. Same Bhumi, 80 marks with proper subjective and reduced syllabus. All right. Hi, everyone. 5 chapters, which are like the same, similar chapters or completely different? Hello, Vinraj. Polymers. Alkenes, allorenes, alcohols, phenols, biomolecules, mostly organic, and electrochemistry. Okay. So, Rafi, personally speaking, even I like subjective. At least, see, there is a point in that, but yeah, this is something which you can use as a for your advantage. You see that this is not just the first time of yours for the board examinations, right? Of objective. This is the same time for NCRD or like for the CBSE Council as well. So they also have to manage their results. Suddenly, they cannot go from 99 percentage, which they used to give 99.8, 99.9, 100 percentage, which people are getting. Suddenly, they cannot move to 80% or like results. It won't help them, right? And the problem with objective is that there is no partial marking. So technically, 100% actually means that you need to give every single answer actually correct. Because wrong means Sida zero. There's nothing like 0.5 or 0.8. So equally, I think boards is also tensed. And this is the thing which you can use for your advantage right now, because you know that the papers are not going to be that tough. This is the first time this way the things are being conducted. You know, JEE mains, the first attempt, first day, like February, it starts with February, right? February, March, April, and May. So the February attempt, the first day attempt in the morning shift paper, you will find the easiest. So, and yeah. But then in JEE, you do have the cutoffs problem. But in CBSE, there is no cutoff problem. So yes, use it to your advantage. This is the best time where you can score well because they are not going to create very tough questions. Okay. Yeah, subjective means where there are short answers, hurriedly, long answers, those kind of a question paper having these kind of questions also, where you have to actually write down in the point-wise or paragraphic manner. Yes. All right. So now let's get started with. Oh, so some people might be having in their school, like some people school take a very high level of models just to make sure that you are like well prepared. Okay, so they give you tough questions. Sometimes they give you like they try to show off their JEE stuff and other things. So they give you very good questions. Yeah, the things that they have never taught in the class, and it's a very common thing which I've observed in schools, particularly when it comes to the pre-board examination. First time with the level of paper is so high that this child, if this person is going to take the paper to the other school will be like, oh my God, do they teach this much? But that is just to decrease your motivation or to like lower down your overconfidence, technically speaking. This is the only reason. The only reason why they do, why these people do it is to lower down your overconfidence. Because see, actually, the paper is very easy for boards. If you'll check, like this time, this is not subjective, so it's not relatable. But otherwise, it is like the, and I quote it, and this is live streaming. I can easily quote it because CBSE cannot challenge me for this. They have given the exact questions from mathematics NCRT examples without even changing the values. They don't even bother to change the values. This has been the scenario in my examination also when I used to give my boards. And even now, the situation is almost the same. And yeah, like some people who have, like in the tuitions, mostly the people who go to tuitions, their school teachers let you mug up those questions that this is important for CBSE, this is also important for CBSE. So you practice them so many times that you mugged them up, including the steps, even the answers. Like now you remember it is 6.93 centimeters square. You remember it by heartedly. So these are the things which actually happen. So like so many times it has happened. Even the dumb students of my class, they were like, they do not know what to write in between. So they started, and towards the end, they just wrote the formula or they just write the things. And then towards the end, they just write the answer. And they got marks. So overconfidence increases, and that is the thing that school does not want. Okay, which is the right thing of school? I know, Larry. It's a very common thing, Vedant. You have all noticed it. Chalo, let's come back to the case. You all got yeah, Nasser. Like this is one thing for you, which you have to salute your school. Actually, they are doing the right thing. I know, Raghav, that is also true. They make you anxious, they make you scared, this activity. But technically speaking, not just believe on yourself. If you have done NCRT with proper understanding, line by line, okay, and line by line, I'm telling you. See, this time, since it's subjective, please expect the questions from in between the lines. Okay, do expect the questions. Okay, like they can ask you out of the following, which all are the isotropic properties or anisotropic properties. So suppose they have given you certain things in your NCRT, let's say refractive index, let's say conductivities. So eventually you will find that these are the options written, only those options which were given in the NCRT. But if you've read it, you might remember it, otherwise you might forget. Two sets for pre-boards and for math, they have two extremes for both sets. One was lengthy and hard, other one was easy. But that was purely luck, Ananya. But I tell you, this sort of luck factor now even works in a CBSE, and I'm very frank at it. Luck factor, sometimes you might have observed people who were quite, you knew them. Okay, so you knew what was the level of the child or your friends, okay, or the friends' siblings. And suddenly you see very unexpected results of them. They are like toppers, or sometimes their marks are too low. So yes, even luck factor works in case of CBSE. So because of that, it does matter here, because it eventually affects it that sometimes if in spite of having a very nice amount of hard work, suppose you got the lengthy and the hard paper, so your paper was not completed, or by chance you could not get the answers for few questions, right? And at the same time, the other person who was way below you, right, because his paper was easy, he was able to secure almost similar marks as compared to you. So it gives you a disheartening feeling. Okay. Yeah, right, Prithvi, true. Those 3 hours are going to decide. Oh, by the way, let's come back to the previous 1.5 hours, last week's, and let's decide your fate for that. Did you guys do your homework? Yeah? Yes? Perfect. Perfect. Now, okay. So there were some questions which were written on the left side. There were some questions which were written on the left side. There were some questions which were written on the left side. Suddenly feel that I am in mountains. Suddenly feel that I am in mountains. Suddenly feel that I am just a second, guys. Just a second. No, I didn't.
मैम आपने यूट्यूब खोल के रखा है साइड में?
Yeah, guys. I hope it's better now. Cool. Thank God. All right. So I don't like hearing myself. All right. So I was discussing that there were certain questions which were to the left-hand side. You didn't receive these notes. You from SP122 batch. Did you ask your teacher? Because I sent the notes at the very same day to your respective teachers. Okay. Did you confirm it with your respective faculty? Okay. All right. So you can ask the faculties. All right. Chalo, that means some of you have not done the homework. Yeah. And I think it's the best thing is that we can discuss these questions only when everyone has done it. Because I want to see where are you basically finding the trouble, the left side questions or the right side questions. Okay. Because they're easy. These are the ones which I'm showing. The ones, yes, these are the left side questions. Rahul. So I'll tell you the difference between the left and the right side. Yeah, I know they're very easy. Yeah, they're very, very easy questions. They're so direct and they all are JEE mains question. They all are JEE mains question of solutions chapter for the year 2021. This year only. These all are the questions on your left for the year 2021. So guys, I told you last class also, if you are done with solutions chapter with proper understanding, okay, with proper understanding, even from CBSE, like even from your NCRT, even if you don't go much, except for just multiplying everything with I. Quantum factor is the only thing that you should know. उसके अलावा अगर तुम्हें कुछ नहीं भी आता ना, it's sorted. It's still sorted, I tell you. Right. So there is 90% probability you will be able to do your solutions question very well. Okay, but if you're done with the entire notes, like all the things which we revised in the last class with respect to that JEE stuff, then 100% you'll be able to do a question based on this. The right side questions are a little tricky, but again, they are not very tough. They are just tricky, and they all are advanced questions. Rahul, it won't help because there was some trouble with my laptop. Okay, so it's not getting saved. In fact, this question is this year's 2021 question of JEE Advanced. All right. So yeah, please ask your faculties, please guys, please ask your respective faculties to share the notes so that we can discuss it in the next class about the entire stuff, right? Well, that would be wonderful. Then. Okay. All right. So now in today's session, we will be starting with solid states. Okay. We're going to start with the solid states. So guys, first of all, let's talk about the solid states. What all do you know about, oh, the class is till 10:30 p.m. IST. Hanji. So guys, I believe you guys have done this chapter. Yes. Oh, that's wonderful if you remember. Now, so what I'll be discussing today is like a quick revision of this entire chapter. Yeah. So we will be having a basic quick revision of this entire chapter. Now, see, when it comes to this chapter, so solid states, what actually happens is CBSE revision. Like, oh, so the CBSE revision of this chapter has been done. Oh, that's awesome in that case. Right. Okay, so let's have a quick brief about it then. So the first thing that you'll talk about is the differentiation of the solids in terms of solids, like in terms of the arrangement of atoms, and that is crystalline and amorphous, where crystalline are also known as this true solids, and amorphous are also known as the pseudo solids, or amorphous are also known as supercooled liquids. Now, the example of supercooled liquids is glass. Oh, wonderful. Quartz. Right. Amorphous are anisotropic. Amorphous are isotropic, whereas crystalline are anisotropic. Right. By the way, what do you mean by isotropic and anisotropic?
Properties of certain physical quantities is different in all direction is isotropic and anisotropic opposite.
So properties are different in different directions, right?
Anisotropic.
In anisotropic. But why are there some properties which are even direction dependent? there are different arrangement of atoms due to the manner in which the constituent particles are arranged, right? And because crystalline particles are following a long range order, yeah, so they have the same way of arrangement throughout the system. Whereas this is not the scenario in case of isotropic or short range order molecules. So for example, if you have a proper crystalline solid, there will be positive, negative, alternately held. Right. So because of randomness, there is something which is known as internal compensation. So that's right, Arya. So everything gets cancelled out. The values and the particles, the manner of forces of attraction, somewhere is strong, somewhere is weak. So overall things get cancelled out. But this is not the scenario in a proper order, where we can see that if I look in this particular direction, there are different constituent particles existing. If you'll go in this direction, then my light has to cross different constituent particles. If I go in this direction, then I am getting different constituent particles. So since the particles are different, very good, Faiza. Done. Now, nice. Hanji. So basically, this is the reason why there are different properties in different directions. And if you talk about the crystalline part, so again, this is one such place where you can expect a question if you're talking with respect to CPSC, that which of the following are true, which of the following are false, and then they can give you the 4 options, which are nothing else but the differences of crystalline and amorphous. Okay. Now, there is also a process which is known as annealing process. So my question is, have you heard about annealing? No? No, no. Which annealing? No. It has nothing to do with ores. It has to do with this chapter, and particularly with respect to crystalline and amorphous. That is why I'm discussing it here. Nothing? No one remembers it? Changing property, converting crystalline to amorphous, okay. Okay, so yes, basically it is a heat treatment. Physical structure gets changed because of heating. Okay. See, whenever you heat something, what happens? Whenever we generally heat anything, what actually happens? Yes. So basically the forces of attraction weakens. Right. The forces of attraction weakens. Agreed. Kinetic energy increases. That's so true. Now, so basically what actually happens in this process is whenever you do this annealing, okay, whenever you do this annealing, what actually happens is it will try to break the bonds. The molecular spaces will increase. That's right. Okay, and because of that, can I say now the forces are breaking, so the kinetic energy of the particles will increase. That's so true. Expansion will take place, right? And because of this, it will change the mechanical and the electrical properties of the solid also. Right? They get changed. Now, because of that, can I say this entire process will reduce the hardness? Yes. Now, if the hardness will reduce, can I say the malleability and the ductility part will increase? Because see, the metals, whenever they're very hard, they are liable to be brittle also. Okay, after a certain temperature. So when the hardness reduces, when something has become a little softer, a little, not very, okay, a little softer. So when you bang it hard, it won't break into pieces. So its ductility will increase. Its ductility will increase. So whatever are the internal stresses which were present, now those stress can be removed. That stress can be removed. So basically it is trying to soften my metal. It is trying to soften the metal, soften the metal. Right? So this is basically your annealing process. And by this process, I can convert a crystalline solid into an amorphous solid. Because of this process, I can easily convert a crystalline solid to an amorphous one. All right. Is this part clear? Make sense? Up till here? All right. Now, along with this, you might have also done another thing in the CBSE revisions. That is on the basis of the number of particles, like the type of constituent particles, you have categorized the solid states into major 4 categories, which are given in your textbooks, right? If the constituent particle is an ion, we'll call it as an ionic solid. If the constituent particle is a molecule, we'll call it as a molecular solid. If the constituent particle is atom, we'll call it as an atomic solid. If it is a metal atom, we'll call it as a metallic solid. And then atoms are even present in covalent solids or the network structures, right? So these are the few things which we have. These are the different types of solids that we have. And on the basis of each of the solids, we have different properties, of course. So it will depend on the force of attraction that what would be the new type of properties that the substance would be bearing. For example, if I talk about ionic solids, yeah, are they good conductors of heat and electricity? Give me an answer. Are they good conductors of heat and electricity?
Only in molten state.
Very nice. So if you'll just say yes, then your answer is wrong. And this is how assertion and reasons are framed, right? So if they'll just write ionic solids are good conductors of heat and electricity, this is an incomplete statement, only in molten or aqueous state. Otherwise, the statement is false. Make sense? Yeah. And the reason why they're very hard is, what is the reason? Why are ionic solids hard? Strong forces. All right. And what are these strong forces known as? Electrostatic or Coulombic forces of attraction. So this will be the answer, right? Ionic solids are, of course, very hard, and there is a line in NCERT which says they are hard and brittle. But the point is, why hard and brittle? Because of electrostatic forces of attraction. Is there any other place which is also having any other type of solid which is also having electrostatic forces by any chance? Is there any other type of solid? Metallic, right. So the people who are giving the answer as metallic is correct. Why? Is of course a question when so many people's had. That's right, Nikhil. It's due to the electron C model. Because as per that model, it says that metals are positively charged kernels and which are lying in a pool of electrons. So there are positively charged kernels lying in the pool of electrons. So there is positive and negative charge, and of course they are attracting each other. So there is electrostatic forces of attraction, though it is not very strong. Because you know force of attraction is directly dependent on, or you might have done it in physics, kq1 q2 by r square. Yeah, that's the force of attraction. But here, the q factor has decreased. If there is an anion, then the q factor will be multiplied with the number of protons also, like the charges part, +2, -2, that way, right? But if it is an electron, the charge value is actually lower. The charge value of an electron is lower. If it had been an anion, then the charge value is higher. Of course, you will take mod of Q in date Prithvi. We are not taking signs into consideration, but the magnitude has decreased. So that's the reason why the comparative forces of attraction are not that strong. But otherwise, yes, this is the reason why metals are hard, again, because of strong forces. Right? And because of the free electron present in them, that is why all metals are good conductors of heat and electricity. Thanks to the free electron. Make sense? Yeah. No, not all. And nothing is all. Yeah. Exceptions. Chemistry loves exceptions, and we love chemistry. So yeah. Okay. So now let's move to the next thing, and that is, in spite of that, in spite of the very strong forces which we quote as the electrostatic, yet the strongest known substances, the natural strongest known substances, diamond, which is neither a metallic solid nor an ionic solid, right? So that's a peculiar thing about nature. So the carbon is like the new boss. So yes, not even just carbon. You see group 14 elements, which are the major ones who form the covalent compounds, right? Diamond and silicon oxide, which is like the silica part of sand. Even they are very strong particles, quite strong particles, and their strength comes from the fact that they're forming a network structure. So more the number of bonds, more is the force of attraction. And yes, difficult will it be to break the bond. So it is not about the strength of the bond, it is about the surface area, which is actually defying the other ones, the other cases. Right? Does this make sense to you? How we are. So basically, it can come to you as an exception, but there is a reason for it. Right? Okay. Now, again, we have this molecular solids, and the molecular solids, we already have 3 further categories, that is polar, non-polar, right? In the polar one, you further have 2 subdivisions, right? That's true. In polar ones, we have, because polar ones are the ones where there is electronegativity difference. And non-polar ones are the ones where there is no electronegativity difference. And that is why its forces of attraction, the force of attraction existing in non-polar compounds is basically van der Waals. Or London dispersive. Whereas the forces of attraction existing in polar molecules could be of 2 types. One is dipole-dipole interactions, and the other one could be hydrogen bond. Right. So basically, protic and aprotic, protic will be having hydrogen bonding, aprotic will not be having hydrogen bonding. Right. Done? Make sense? Now, there are the next thing, which is the different types of lattices. So when we talk about the arrangement of elements, right? So the arrangement of elements in a 3-dimensional picture is known as a crystal lattice. And the basic repetitive unit, which is responsible to do this arrangement, is known as the unit cell. Right? This is the thing that we have already covered. Now, when you talk about these unit cells, there is one more thing that you must have done. That is, these unit cells contains the atom at specific locations. And those locations are known as the lattice points. Right? The lattice points. Now, when you just cover up the fact that, let's say, there is one atom here, another atom here, then one atom here, and another atom here, right? Now, you connect the 2 atoms. Again, you will find another place which were also having the atoms. And again, you do the same sort of connection. Okay. Now, the distance between the 2 lattice points, how do you get that? How is it 2R, Ayan? 2 into radius of the 2 atoms? I cannot be certain, no? It could be even further away. Who said that they have to be touching each other? This is my assumption. So basically, this part, under the condition for it least vacant spaces now. So this part is actually checked with the help of X-ray crystallography. See, in your PREC NCRT, what you have done is that in a unit cell, what they have told you is that there are three cases. There is A, H length, there is B, and then there is C, right? These are the three things that they have done. So they said that there are two things on which your unit cell is dependent on. First is known as the intercept, the unit cell intercepts represented as A, B, and C. Second is the interfacial angles, right? Where the angle between A and B is known as gamma because alpha, beta, gamma is the Pyara Greek language. And they are the ABC of their language. So in one plane, if there is A and B, then the third one has to be C. And C in Greek is basically gamma. Same way, if you have already used this plane where there is A and C, so to complete the triad, you're left with B. So beta. And same way here, alpha. So what they talk about is that these are the two things on which your unit cell is dependent on. But then this is not the part is, yes, you're right. Indeed, your 7 crystal systems, which you talk about, 14 revised lattices, 7 crystal systems. So you say that they're coming from A, B, C, and alpha, beta, gamma, right? But then how is it actually coming? Who decided when to say A is equals to 2R? Who said when to decide A is equals to 2 root 2R? How on earth did you decide that? So basically it was decided not by these people. It was done by X-ray crystallography, by X-rays. So you bombarded X-rays. X-rays has a very strong importance in the entire science because of its high penetrating power. Exactly, Neil. Because of its high penetrating power, it has a very strong influence. If you talk about this part, yeah. So this part is basically a part of physical chemistry or physics, right? Again, the very basic thing of X-rays is what you have heard very often in biology. Yeah. हाथ टूट गया, पैर टूट गया, फटाफट से get your X-ray done. So because of its high penetrating power, it can go and check whether there is any bone broken or not, or whether there is a muscle tear. X-ray again finds a very high importance. You remember Mr. Henry Moseley? He was the guy who found atomic numbers. Prior to that, no one knew about it. And he was able to find out atomic number thanks to these X-rays. Right. So this X-ray had been a revolutionary change in the world of science. The same way, when you talk about these solid structures, they were found with the help of X-rays. And there was something which is known as X-ray diffraction. It's a part of optics. It's a part of optics. So when light falls on it, you see there is this normal. So yeah. Now, of course, there is some penetration. So we are talking about these penetrations also eventually. And this is the distance between the two planes. The distance between the two planes. Now, what are the planes? This line and this line. You remember refractive index was anisotropic and this and that and do, which NCRT has mentioned. Now, why has that even arrived? But like, why was there a question about refractive index? Why do you want to even check it? We checked it because of X-ray diffraction, because we refracted the light. Okay. And because of that, we found out the distance between the two atoms. And this is found with the help of this equation, which is known as the Bragg's equation. Okay. So lambda is a wavelength, and d is the distance between the two segments. Theta is the angle. N is the order of refraction. Yes, with the vertical. So angle is the theta is the angle of refraction. So basically, it is not the reflection angle, it is the refraction angle. Oh, this one. Right? Make sense? Up till here? N is the order of refraction, yes. Eventually, we'll be learning everything in optics, I believe. But it is like, you remember N lambda, MVR? Like, okay. What does N lambda, optics over in that? And you still do not know this? How's that even possible? Okay. So now, wave optics isn't fully complete. Okay, sure. Now, basically, if you talk about you remember number of waves? What does number of waves signify in an atom? The shell number. Do you remember that? Yeah. So the circumference is like this way, because we know that an atom is actually acting as a wave as well as a particle. So it is dependent on that way. So angle of refraction when it comes. So if you talk in terms of atom, then N can also represent your shell number, okay, or the number of waves. And otherwise it will like if otherwise it will depict the order of refraction. Okay. Now, if you talk about the 7 crystal systems, so yeah, my way of remembering the 7 crystal systems is like caught, empty, red-handed. So these are the 7 crystal systems that we have. Refraction, refraction or diffraction. Okay. Basically, refraction. So these are the 7 crystal systems that we have. And it symbolizes C for cubic, O for orthorhombic, T for tetragonal, M for monoclinic, T for triclinic, for rhombohedral, H for hexagonal. No, I just spoke it up. Oh, that's nice. Again, that will also work. Cubic, tetragonal, orthorhombic, monoclinic. And rhombic. Okay. Triclinic, hexagonal, and rhombic. So Vedant is telling about cute our mother. So cubic, tetragonal, orthorhombic, MO for monoclinic, T for triclinic, HE for hexagonal, L for rhombohedral. Queen. Ever start in the CBSE class? Oh, that's wonderful. So the important thing is that you should be knowing anything. Any which way, you just need to know this. And frankly speaking, for CBSE, it's actually required, I tell you, because CBSE can ask you, okay, this is cubic. What are the correct conditions for it? Okay, so they can write 4 options and the 4 different conditions. At the same time, it could be a reversal. There could be like some conditions given, and they can ask you out of the 4 options, which is the right system which follows these conditions. So these are the things which you need to know. Right? Now, after that, there are these things called number of atoms and the packing fraction. So I believe you might have done this part. Number of atoms in every unit cell. So you have primitive and non-primitive, right? In the primitive one, in the unit cell categories, we have the primitive ones where there is only one type, and that is simple cubic. And non-primitive ones are 3 types: FCC, BCC, and ECC. Where we know that simple cubic, the effective number of atoms are 1, right? And all the atoms are present at the corners. Whereas for FCC, the effective atoms are 4. For BCC, 2. Wonderful. For ECC, effective number of atoms are 2. Okay. Now, let's move to the next thing, which is the packing efficiency. So packing efficiency, what does that represent? Space utilization. So amount of space utilized divided by the total available space. Volume occupied by all the atoms divided by the total volume of the system. That's right. And the system I'm already considering cubic. Thanks to this chapter, I'm not going to go in detail about the other different types of crystal systems. Right. So since I'm talking about cubic, it is the A cube part. So for packing efficiency of primitive, is 52.4. And it's good if you remember it because these are again the direct questions which are even have been asked in JEE. Okay, JEE भी बहुत सीधा सीधा directly पूछ लेता है. So they can ask you about the percentage occupied. They can even ask you the percentage unoccupied. So this is simple. For FCC it is. For FCC, bache, that is 74. FCC. BCC is 68. Right. Now, FCC is also like is also known as HCP, hexagonal cube stacking, or CCP structure. These are the other names of it. And what is the coordination number in case of HCP or CCP? That's 12. Right. So more the coordination numbers, that means closer the atoms are, and hence effective is the packing. In case of BCC, coordination number is 8. Right. So BCC is also known as a CSCl type structure. Not BCC is known as. CSCl is like the most common example of BCC structures. Okay. For FCC, the most common example is rock salt type. That is NaCl. Right. Where in NaCl, the sodium atoms lies at, where does the sodium atom lie? Right, Pranshu. The octahedral voids. They lie at the octahedral voids. And what is the location of an octahedral void? At centers plus body center. Right. Whereas chlorine lies at the lattice point, which are FCC lattice points. Right. That is corners plus face centers. And what is the actual molecular formula of NaCl? Not empirical, the actual. The actual molecular formula of NaCl is Na4 and Cl4. NaCl is an empirical molecular formula which we are using. And that you can find out using this information. That there are 12 edges and each edge is having 1/4 sharing contribution. And there's one atom at the body center. Same case here. Corners plus face centers. So you'll find that effective atoms of sodium and chlorine are 4 each, and thus its actual molecular formula is Na4Cl4. Does this part make sense to everyone? Yeah? Sure? Oh, that's wonderful. In that case, if I might ask you, are you guys aware about, you guys knew about coordination number, right? Now, I'm drawing a structure. All right. In this structure, right. So in this basically structure, there are some X atoms, which are green atoms, and Y atoms, which are Y. I want to know what is the first coordination number in this, second coordination number in this, and the third coordination number, which is existing in this case. And just a sec. What is the first coordination number, the second coordination number, and the third coordination number? Right, Nihir? Others? Right, Azhar? Now you have to give me the coordination numbers. You gave me the formula, though the formula is wrong. No, Avinraj. No, Parth. No, Dhruvi. Akshat, correct. Akshat, third. No, no, no. Second coordination number is correct. First and third are wrong. Dhruvi, correct. Prithvi, first coordination number correct. Second and third are wrong. Ansh, no, none of them is correct. All right. No, Dhara. Oh, first number is correct. Okay. Now, let's see. What is the concept? First of all, what Bhumi gave me as an answer, I would like to actually see that. Guys, what will be the formula of this compound? This X atoms and Y atoms. What will be the formula of this compound? No, no, no. I might have missed it. The empirical formula a real formula, whatever you want to give. What will be the formula of this compound? Formula will be X4Y4 or XY, right? Where X atoms are lying at the corners, do you all agree? Along with face centers. Y atoms are lying at all the edge centers plus body center. So basically this compound is referring as an NaCl type structure. NaCl type of structure, right? Now in this, now let's talk about the things here. Now when I say first coordination number, second coordination, so coordination number actually meant the nearest neighbor, right? Coordination number meant the nearest neighbor or the closest touching atom. So when it comes to closest touching, so I would be looking at a unique atom. So I can see the central atom is the only one of its kind. Rest all the atoms, the ones which are present at the corners, the ones which are present at the edge centers, the ones which are present at the face centers are more in number. So there are 6 face center atoms, 8 corner atoms, 12 edge center atoms, but the body center one is just one of its own. So let me take that as the reference atom. Now, when I say the nearest neighbor, so nearest neighbor means it is dependent on the distance, right? Nearer to me is the distance dependent thing. And for any time, wherever you want to write the distance, so for that, I need a reference point. Yes or no? For any distance, I need a reference point. Right? This is a basic thing you've done in physics. So my reference is this pyara sa central atom. Now, with respect to this central atom, there are 3 types, basically, that there are 3 different locations at which the atoms are present. For instance, the face center ones. Yeah, I have to change. The face center ones is one type, right? The edge center ones are the second type, and the corner atom ones are the third ones. Right. Now, if you talk about the face center atoms, so they are lying at a distance of a by 2 if I consider a as the edge length of the entire atom. Yes. So this is at a distance of 0.5 a. Corner atoms are approximately root 3 by 2, no? A, which is nearly 0.8. And the edge center atoms are like almost 0.7. So from here, I can look at the distance. My nearest one is 0.5. So that means all face center atoms are the nearest ones to me. And there are total 6 face centers. They all are equidistant. Same way when I talk about the second coordination number, which will be, now everyone in the chat, now you guys can answer. 12, because all edge center ones are equidistant to me. And then the third one would be 8 because of all corner atoms. Does this part make sense to you? Yeah? Yeah. So if I ask you the fourth coordination number, then this is tricky. The moment I ask you the fourth coordination number, that 0? No, with that. Yes, Nehir, no, Ansh. Yes, Prithvi. No, Aryan. No, Bhumi. No, Abhinraj. Ansh, no. So basically, to how many cube in the entire lattice is this cube touching? 6 cubes, right? Oh, right. And then these 6 cubes, the fourth coordination number will be this one. The next cube with the distance of one center and the second center will be, the total distance will be A, right? The total distance will be A. So all the body center atoms to which this cube is touching. But this cube can only touch from 6 sides, right? Because it has 6 faces. Right, Avinraj?
Yes,
From
ma'am.
left, right, top, bottom, front, back. That's
I
it.
just thought of diagonal touching also, which is not correct.
Yes. So that is why the fourth coordination number will move to the next unit cell and the value will be 6. Does this make sense to everyone? Yeah? Perfect. Now, then let's do the next thing. So in this, you might have also done about this stuff called the voids, right? Now in the voids, we basically have the major 2 types of voids. You have practically done the octahedrals and the tetrahedrals, right? So you've already drawn the diagram, I believe. Yeah. And tetrahedral void, octahedral void with a coordination number of 4, with a coordination number of 6. You must have drawn those normal triangle, then ulta triangle on it and stuff and stuff and stuff. Yeah. Then yes, someone even wrote it. So if the number of atoms, number of effective atoms in an atom is n, then your tetrahedral voids will be 2n and the octahedral voids will be n, right? This is also something we have done. Another thing is that if you talk about the tetrahedral void, now the atom which you're trying to fit in it, okay, the atom which you're trying to fit in it, what should be, or what could be the radius of that atom? In that void, whatever atom you're trying to fix in, what is the radius of that atom? Okay, so here is the formulas majorly. Now, technically, the tetrahedral void, the radius of a tetrahedral void is 0.225 r, and the radius of an octahedral void is 0.414 r. It means it is almost 40 times lesser than r, where what is r? R is the radius of an atom lying at lattice point. And voids are basically the interstices, the short spaces. So when you talk about the lattice point, those are the areas which are majorly occupied by an atom, a bigger atom. So When these atoms will take the positions, then the small spaces so left in between, these small spaces so left in between, these are basically the types of voids that we get. So of course, you can see the size of these spaces is comparatively smaller. So the atom which can be fit into it, or the type of substance which can be fit into it, has to be a small substance, right? So this is the way by which we write it. And in general, we give the view as tetrahedral voids as these. These are the radiuses. Okay. Is this part all right? Clear to everyone? Great. Then, just like we have NaCl type of structures, and basically we have, like we discussed about this BaCl, CaCl structure. At the same time, we have other structures also. Okay. For example, we have a zinc blende kind of structure. We do have a structure which is known as a zinc blende type of structure. ZNS is zinc blende, which is the ore of zinc. Now, in this type of structure, basically, now in general, your anions are the ones with the higher size as compared to cations. That is why in most of the places, what you'll see is that the anions, because their size is bigger, they are the ones which are trying to occupy the lattice points. Okay, generally, because anions are larger in size, so they try to occupy the lattice points. And the cations, because of the smaller size, they can easily get accommodated inside the void. So, right, here, when we talk about the ZNS type of structure, the sulfide ions are occupied. These are the anions, so they occupy the lattice points, and the lattice point is FCC. They take up FCC, whereas zinc ions occupy half of the tetrahedral voids, or you write it as alternate tetrahedral voids. Right? We have another type of structures, another type, which is known as fluoride. Fluoride. Now this, because whenever we talk about these structures, these are the ones which are found in a specific molecule. So fluoride type of structure was first found in calcium fluoride. Now, why was this compound so important? Because it is the important ingredient of your toothpastes. A very important ingredient. Most of the toothpastes that you have are the ones which are having fluoride in it. Most of the toothpaste that you find, you can even Google it. They are fluoride-based toothpastes. Okay, now in different countries, there is different quality of water which is supplied. For instance, if I talk about a country like India, here the quality of water is not very rich. Now, on what basis do we define the quality of water? So we define it on the basis of the minerals so present in it and the quantity of those minerals. So whether they're lacking, whether they're deficient, whether they're high in amount, whether they're surplus. So minerals and their ppms, the things which you have done in environmental chemistry last year. So technically you need fluoride. So calcium fluoride is like one of the best things because eventually your teeth requires calcium as well as fluorine. So that, but of course in a very, very less quantity. And that is why the fluoride is given or is supplied via toothpastes. Right. That is why this structure was very important. This compound was very important. So when we talk about the structures of it, this is like a peculiar structure in itself, where it is the calcium ions which are taking the lattice points, FCC. And it is the fluoride ions which are taking or which are occupying all the tetrahedral voids. Right. A structure which is opposite to it, a structure opposite this is known as an anti-fluoride structure, which is the last of our category. And in this type of structure, basically it is like the complete reversal, which is anions will take up the lattice points. Example is Na2O, a very common example. Yeah, Li2O, so FCC. Cation is taking all the tetrahedral voids. Right. Now there is another one thing, which is the density. Oh yeah, spinels, of course. So spinels and inverse spinels we have to do. We'll see about the time, because I believe that if in India the time is 10:30, like at some of your location, the timing must have crossed it. There are some of the people who are from those countries which are ahead of us. I was seriously feel bad for them. All right. So we'll come to spinals and inverse spinals. But before that, we'll just have a short discussion about another thing that you have done is density. How to find out density? So right, Z is the atoms, the number of atoms into the molecular mass divided by Avogadro's number into the volume. Oh, not an issue. I understood that. Yeah. So this is basically the mass of the unit cell. This part is depicting the mass of the unit cell, whereas this part is depicting the volume of the unit cell. And hence the density. Right. Okay. Now, if I talk about the thing about these examinations, right? They ask you a lot of questions based on this, the direct questions of densities. So the densities are this way. Now there are, so let me ask you a question. Okay. Okay. But instead of asking you a direct density question, I'll be asking you some other question, because most of the density questions, they're not tough because they're direct application based or direct formula based questions. Yes, they're calculative. So this is the part which makes it lengthy. And thus, it is my suggestion to everyone, you have to make it a rule that wherever the calculations are big, long, please do those questions at the end. Even if you're using approximations, right? See, even if you're doing the approximations, like even if you're considering 6.022 as 6, right? Until unless the numbers become so easy while you're doing the things, right? And these approximations will only work when the options are away. Like for CBSE, definitely it will work. Okay, I believe that with respect to CBSE. that it will definitely work because it is CBSE. Right. So this is approximate things. When you put it, you will get an answer because options will be not, the answers won't be close by. They will be far different from each other. So you will be getting the answers. But if the options are close by, in that case, if you have to do like a better effort at the things, please do those questions towards the end. Now, most of the physical chemistry questions, now in this syllabus of your CBSE Term 1 examinations, most of the questions are from organic, like chapters are covering up organic, then there are physical, and the third one is inorganic, right? So organic are all reaction-based questions, mostly. There would be few distinguishing questions, and those test-based questions, distinguishing test, and few reason-based questions also would be there, I'm pretty sure. Because this had been the case of boards. Boards are used to ask the questions like that. Yeah, even when the boards were like subjective, there were 3 to 5 marks for distinguishing based questions. Those questions based on distinguishing test. If you have reason based questions, again, they were 3 to 5 marks. Then conversions, again, are 3 to 5 marks. Conversion based questions. So all these questions you are going to find in your term 1 examination, just with options. That's it. But definitely there will be questions. And reasoning based is like the distinguishing test of phenol and benzoic acid. That phenol does not react with NaOH, but benzoic acid does. So those kind of things. Bayer's reagent test, bromine water test, iodoform test, right? All these things must be Lucas reagent test. Phthalate tolerance cannot be asked because you're not having aldehyde. Oh, but you are having sugars, yeah, biomolecules. So yeah, over there they can ask you. Reducing sugars and non-reducing sugars, and sucrose is the only non-reducing sugars. Yeah, like the stuff. Best way to tackle assertion reasoning questions. Again. Oh, sorry. Phenol and benzoic acid distinguishing test is the sodium bicarbonate, not NaOH. NaOH reacts with both, but sodium bicarbonate liberates or gives effervescence exclusively with benzoic acid and not with phenol. Yeah, and see, for assertion reasons, I tell you the best way is like in CBSE doesn't matter because any which ways there is no negative marking. So I would say do all the questions, whether you know, you don't know, Jai Mata Di, and then give an option. See, this is how we, even when you do not know the answer. For those choice ones, are you talking now?
Each section only first particular number of questions will be taken.
Yeah, like the first 20, and then the next section is again 20, and then
yes, ma'am. Out of 25, 20. Then next out of 24, 20. Yeah. Then again 5, ma'am.
Yeah. Every section is going to have choices. Yeah, case study ones may to 5 out of 6. So yeah, that's true. But for the questions where you are like, it's not with respect to all the questions because of choices. It's with respect to the fact that if you're talking about the 20 questions, either you know the 20 questions. अब तुम stuck हो गए कि 18 questions तो मुझे पता है, where I'm certain. अब कौन से 2 questions choose करूं? Right, the remaining ones. In case you're stuck that way. Yeah, case study questions में. There could be a possibility that when you see those case study questions now, you're stuck, like you know 3 or 4 very well, but then you're stuck between the 2 questions. So first thing is like always go with your intuitive feeling. That's my first thing. Because in examinations, this is the best thing which will work for you. Intuitive feeling. And generally, people regret it when they come back home and they were like, gosh, I did that. I knew this. I thought that the answer will be C. Why didn't I do that? This happens with most of the people, but a lot of times, I believe. So this is the approach which we need to take only when your number of choices are not being able to be completed. Second, and then in those cases, either go with your calculative guesses or go with your real answers. Then third, like another case which happens is like when it comes to those assertion reason based questions. See guys, look for those lines where you are 100% sure that this part is false or this part is true. Mostly confusing portions are where between A and B options. वो problem है. C and D तो कभी problem थे नहीं आज तक. Right. So whether the reason is the correct explanation or not. Now that thing can be tackled with NCERT. Okay. They can be only tackled with that because see, for that you have to be logically very strong. And there is no trick for you to be logically strong. That thing will only come up with the level of preparation that you have done. Right. But yes, just for your help, I'll tell you one important thing, very, very important thing for NC, like CBSE. You know, for CBSE, NCERT is its friend. Yeah, the best friend. So I believe most of the questions will still be the in-text or the back exercise questions, like in a twisted manner, in the form of an MCQ, but they will be that way. Apart from that, see, there are loads of books which are circulating in the markets, yeah, MTGs and Cengage, and everyone has published their books for CBSE Term 1 examination, Term 1 examination. Indeed, they're good books. But nothing can compete in NCERT when it comes to CBSE. And I'm telling this with experience. So NCERT, you have to be like 100% sure about all your in-text and back exercise questions. Just be ready that they will be asked in a different manner. Okay, you have to be ready in your head with respect to that. Second, for question practice, you can go for NCERT exemplar because this time they are going to give it due importance. Definitely, they're going to give it due importance because you see, this examination is not just conducted for the privileged students, but also for the rural areas. And they cannot afford fancy books with a cost price of 200 rupees and above for a single subject. Oh, that would be very, very difficult for them to buy. Right. So, and it will not be feasible for the government to supply free copies for that also, technically speaking. So NCERT exemplar is like one-stop solution. First, it's a cheap book. Right. Second, just like NCERT exemplar is a cheaper book. Second, it's manufactured by NCERT. So of course, they're going to trust their stuff more than anyone else's. Third, it has all the MCQs and assertion reasons and everything which is present. Right. Another important thing is that this book's online PDF is also easily available, like in the CBSE website only. Right. So this is easy to access, cheaply available, easily available. So of course, this is going to be their guiding stuff. Please do all the single correct. In fact, do more than one correct also, just for your knowledge. And do all the assertion reasons from here. I believe most of the assertion reasons after doing from exemplar, you'll be able to tackle because I am having a bet that they are going to ask similar questions from sample paper, which they have published, and exemplar. You can rely on this more than any other book. Right. So that's going to be the scenario. All right, we have left with with other stuff, that is the properties and spinels and row spinels and properties, as in, yes, defects, then electrical properties, magnetic properties. Take care. So yeah, we will be covering it later in the next class. Yeah. Sample paper exemplar बिल्कुल चाट डालो, and don't forget NCERT, basic NCERT, वो तो बिल्कुल मत भूलना, अच्छे से कर. All right, that's all from my end. Bye guys, take care, all the best, enjoy your
Thank
day.
you, ma'am. Bye, ma'am.
Bye bye.